Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Greetings, esteemed audience. Our discussion today revolves around the transformative power of fuzzy logic in decision-making. It empowers systems with flexibility, user-centricity, and the ability to navigate uncertainty. From automation to AI, fuzzy logic optimizes processes and enhances interpretation. While challenges exist, integration with other technologies and ongoing research promise even greater advancements. How does fuzzy logic improve the flexibility and user-friendliness of decision-making models compared to classical logic approaches?
Fuzzy logic improves flexibility and user-friendliness in decision-making models by allowing them to handle uncertainty and imprecise information more effectively than classical logic approaches. To understand flexibility, imagine you're trying to decide how hot to set your bathwater. With classical logic, you might only have two choices, too hot or too cold. But fuzzy logic lets you think in shades of warmth, like warm enough or a little cooler, allowing you to create a more tailored experience based on your comfort level. When it comes to user-friendliness, fuzzy logic uses simple if-then rules that are easy to understand. For example, if it's cold outside, then you might want to wear a jacket. This approach mimics how we naturally make decisions in everyday life, where we often rely on vague or imprecise information. It feels more like having a conversation with a friend about what to wear rather than following strict, complicated rules. Furthermore, fuzzy logic is robust, meaning it can still make sensible decisions even when the information isn't perfect. Imagine a washing machine that can wash clothes based on how dirty they are, rather than just following strict settings. This ability to adapt to real-world uncertainty makes fuzzy logic a powerful tool in decision-making.
Can you discuss some specific real-world applications of fuzzy logic in automation, or AI, and how its ability to handle imprecision has led to tangible benefits in those areas?
Fuzzy logic has found practical applications in various areas, particularly in automation and artificial intelligence, by effectively handling imprecision and uncertainty, which leads to significant benefit. In automation and control technology, consider how fuzzy logic is used in washing machines. Traditional machines might only have fixed settings, like normal or heavy wash, which can be limiting. With fuzzy logic, the washing machine can assess the weight of the laundry and the water temperature, creating a more customized washing cycle. This means it can decide on the best wash intensity based on real-time conditions, such as whether the clothes are lightly soiled versus heavily soiled. This adaptability improves washing performance and helps save water and energy. Another example is in air conditioning systems. Rather than simply turning on or off based on a set temperature, fuzzy logic allows the system to make nuanced decisions. It can consider factors like humidity and how many people are inside the room, adapting the cooling level more smoothly to maintain comfort. This results in a more comfortable environment and efficient energy use. In the realm of artificial intelligence, fuzzy logic is valuable when dealing with uncertain data, such as images or sensor reading. For instance, if an AI is trained to identify objects in images and the quality of the images is not perfect, classical logic may struggle to give accurate results. However, fuzzy logic can better handle these imperfections by allowing for partial truths. This means that the AI can still make reasonable guesses about what it sees, even when the input data is vague. Overall, the flexibility of fuzzy logic leads to more precise decisions while enhancing user-friendliness and robustness, enabling systems to operate effectively in the real world where uncertainty is a constant.
What challenges or limitations does fuzzy logic face in its implementation, particularly in complex systems, and how can these challenges be addressed?
Fuzzy logic faces several challenges and limitations in its implementation, especially in complex systems. Here are the key challenges and how they can be addressed. 1. Complexity. As the number of parameters and rules increases, fuzzy systems can become very intricate. Imagine trying to cook a dish with many ingredients and various cooking methods. It can get confusing quickly. To address this complexity, it's important to simplify the system wherever possible. This could mean limiting the number of input parameters or prioritizing the most critical rules to keep the decision-making process manageable. 2. Subjectivity. The choice of membership functions in fuzzy logic can often be subjective. This is like deciding how hot or cold is defined in a thermostat. Different people might have different opinions. To mitigate this issue, it is beneficial to involve experts in the field during the development process. Their knowledge can help create more accurate and effective rules that are less dependent on personal bias. 3. Maintainability. As complexity increases, maintaining the fuzzy logic system becomes more challenging. Imagine trying to tune a complicated musical instrument. It requires constant attention and expertise. To enhance maintainability, implementing clear documentation and structured frameworks can help keep track of how the system operates and evolves. Regular reviews and updates can also ensure the system continues to perform effectively. By recognizing these challenges up front and taking proactive steps to simplify, involve experts, and maintain the system, the benefits of fuzzy logic can be fully realized in complex applications.
How does the integration of fuzzy logic with other computational techniques, such as neural networks or genetic algorithms, enhance decision-making capabilities in systems facing uncertainty?
The integration of fuzzy logic with other computational techniques, such as neural networks or genetic algorithms, significantly enhances decision-making capabilities in systems dealing with uncertainty. When fuzzy logic is combined with neural networks, it allows the system to learn from data while still applying fuzzy rules. Think of it like a teacher who uses both intuition and facts to help a student learn. The neural network can process complex patterns from data, while fuzzy logic helps interpret those patterns using imprecise values, leading to more accurate predictions. For example, in image recognition, a neural network can identify objects even if they are partially obscured, and fuzzy logic can then assess how certain it is about that identification, improving the decision on whether to trigger an action. Similarly, when fuzzy logic is used alongside genetic algorithms, which mimic the process of natural selection to solve optimization problems, it can help refine the solutions generated by these algorithms. Imagine a gardener who selectively breeds plants for better traits. Fuzzy logic allows the gardener to consider various qualities of the plants, like size and color, in a flexible way. This helps the genetic algorithm find better solutions by evaluating many potential options in a nuanced manner that goes beyond simple best or worst choices. Overall, the combination of fuzzy logic with these techniques enhances flexibility and robustness in decision-making. It allows systems to address uncertainties and imprecise data more effectively, resulting in improved outcomes in various applications. From AI to business decision-making,
What future developments or research directions are being explored in the field of fuzzy logic to further enhance its applicability in decision-making processes?
future developments and research directions in the field of fuzzy logic aim to enhance its applicability in decision-making processes across various domains. Here are some key areas being explored. 1. Integration with machine learning. Researchers are focusing on combining fuzzy logic with machine learning techniques. This integration can help systems learn from data while still applying fuzzy rules, leading to better decision-making in uncertain environments. For example, machine learning models could be trained to understand complex patterns, while fuzzy logic could interpret those patterns with flexibility. 2. Improved robustness and complexity management. There is ongoing research to develop methods that make fuzzy systems more robust while managing their complexity. This includes creating better algorithms for simplifying rule sets and improving the efficiency of fuzzy systems in processing large amounts of data without becoming overly complicated. 3. MIMI. Applications in big data and IoT. As the volume of data grows exponentially, fuzzy logic is being researched for its application in big data analytics and the Internet of Things, IoT. Fuzzy systems can help analyze imprecise data generated by numerous devices, making it easier to derive meaningful insights and enhance decision-making in real-time scenarios. 4. VAR. Advanced membership functions. Developing more sophisticated membership functions can also enhance fuzzy logic's effectiveness. Research is underway to create dynamic or adaptive membership functions that can change based on the context, allowing for more nuanced decision-making. 5. Interdisciplinary applications. Researchers are exploring the application of fuzzy logic in various interdisciplinary fields, such as healthcare for diagnostics and treatment planning, and environmental science for modeling complex systems impacted by uncertain factors. By focusing on these areas, the future of fuzzy logic looks promising, with the potential to significantly enhance its role in decision-making processes in an increasingly complex and uncertain world.
Thank you all for joining us today. We've explored how fuzzy logic enhances decision-making by handling uncertainty and imprecision. It allows customization and adaptation to real-time conditions, enhancing automation in washing and air conditioning, and improving AI's image recognition and data interpretation. While it faces challenges in complex systems, its integration with neural networks, genetic algorithms, and machine learning expands its capabilities. Ongoing research aims to improve its robustness, integrate it with machine learning, and explore applications in big data, IoT, and interdisciplinary fields. Remember, fuzzy logic empowers us to make flexible and user-friendly decisions, even in the face of uncertainty. It's a powerful tool that continues to shape the future of technology.